Picture a realm so unimaginably distant that the sun itself is reduced to a mere brilliant freezing pinprick, lost in an endless ocean of perfect black. Out here, in the permanent and unforgiving twilight, massive dwarf planets coated in solid nitrogen and rust-red organic ice drift silently through an ancient undisturbed graveyard. It is the ultimate boundary line, a place where the familiar life-giving warmth of our planetary neighbourhood finally surrenders to the profound icy mysteries of interstellar space. If we were to look closer at this frozen wilderness, we would see dormant, icy wanderers occasionally being nudged from their slumber by invisible gravitational whispers. These dislodged fragments begin a slow, perilous fall toward the inner solar system, eventually violently erupting into spectacular glowing comets that have terrified and mesmerized humanity for millennia. They serve as fiery, high-speed messengers of a chaotic past, carrying the pristine chemical secrets of the deep dark across billions of miles of empty vacuum. Surprisingly, the most distant of these icy fragments do not wander randomly through the abyss, but instead move together in a haunting, synchronized mathematical pattern. Their stretched, eccentric orbits all lean in the exact same direction, pointing toward a massive, unseen influence actively sculpting the far reaches of our star system. It is the signature of a gravitational phantom, a hidden giant shepherding the debris of creation in the deepest, coldest shadows of the sun's domain. Imagine leaving the heavy gravity of your daily waking life completely behind, allowing your mind to float weightlessly alongside these ancient silent monoliths. Right now, in the quiet sanctuary of your own room, there are no more puzzles left to solve, no vast distances you need to cross, and no freezing cold you need to brave. You're safe, cocooned in a soft landscape of blankets that shields you from the chaotic forces of the outside world. These wonders are yours to inherit as you sleep, delivered to your resting mind as a beautiful slow-motion tapestry of cosmic history and celestial mechanics. The mattress supports your physical frame entirely, allowing your steady breathing to naturally synchronize with the slow, unhurried, rhythmic turning of the outer planets. Let the peaceful darkness behind your closed eyes perfectly mirror the empty, serene expanses found at the very edge of our solar system. This cosmic structure is a breathtaking monument to the earliest days of our universe, waiting patiently in the dark to share its billion-year-old secrets with you. As your consciousness gently drifts further and further away from the waking world, we begin our slow journey into the twilight. Deep within the outer reaches of our solar system lies a massive shadowed ring of icy bodies left over from the very dawn of our cosmic neighbourhood. Deep within the outer reaches of our solar system lies a massive shadowed ring of icy bodies left over from the very dawn of our cosmic neighbourhood. Long before the rocky inner planets cooled or the gas giants settled into their majestic orbits, this primordial debris field was already taking shape in the freezing dark. It stands as a silent monument to the chaotic forces of creation, preserving the original building blocks of the universe in a state of suspended animation. These ancient fragments never coalesced into a single world, remaining instead as a scattered multitude of pristine relics. Each frozen lump of rock and volatile ice carries the chemical memory of the solar nebula, offering a flawless window into an era more than 4 billion years in the past. To look upon this distant frontier is to stare directly into the cradle of our origins. Navigating this profound emptiness, one senses the staggering scale of a planetary graveyard that refuses to truly die. The remnants of formation drift onward, whispering secrets of a time when the sun was nothing but a violent, newborn star. This colossal structure spans a seemingly endless region of space, beginning just beyond the gravitational reach of Neptune's turbulent blue orbit. Where the familiar procession of major planets finally comes to an end, a new and far more mysterious architecture takes over the void. The sheer volume of this outermost territory dwarfs the relatively compact neighbourhood of the inner rocky worlds. Crossing the orbit of the final ice giant is like stepping over the threshold of a great invisible door into the true wilderness of the solar system. The gravitational tides of Neptune serve as a majestic, rhythmic boundary, constantly shaping the inner edge of this expansive zone. Beyond this planetary shoreline, the icy domain stretches outward into an abyss that challenges our very comprehension of scale. Scientists map this expanse not by distinct landmarks, but by the subtle, sweeping gravitational currents that define its incredible breadth. It is a sprawling empire of twilight, operating under a completely different set of physical rules than the warm, sunlit realms closer to home. Trillions of frozen fragments drift silently through a celestial expanse so breathtakingly wide that it takes light itself several hours to cross from one side to the other. Here, the frantic collisions of the inner solar system are replaced by an eternal, slow-motion ballet performed in near-total darkness. The distances between individual objects are often so immense that a traveller standing on one world would see nothing but empty blackness stretching to the next. Consider the isolation of these lonely wanderers, suspended in a vacuum where the concept of time seems to stretch and distort. They are trapped in elongated orbits that take hundreds, sometimes thousands of Earth years to complete just a single revolution. Each silent monolith traces an invisible arc through the void, completely unaware of its distant neighbours. This majestic emptiness is perhaps the most profound characteristic of the region, emphasising the sheer vastness of our star's outer domain. It is an ocean of nothingness peppered with microscopic islands of ice, drifting onward through the turning of cosmic ages. Imagine standing on the rugged surface of a Kuiper Belt object, wrapped in the eternal twilight of the outer solar system. If you were to look up from the frost-covered ground, the familiar blinding orb of our sun would be nowhere to be found. Instead, the anchor of our planetary family appears merely as an unusually brilliant star, an icy pinprick piercing an impossibly black canvas. Without an atmosphere to scatter the light, the sky above is a permanent star-studded vault that never transitions into day. The shadows cast across the jagged icy terrain are sharp, bottomless, and absolute, offering no gentle gradients or warming hues. It is an environment of stark, uncompromising contrasts, where the dim silvery glow provides barely enough illumination to navigate the crags. This hauntingly beautiful vista radically redefines our relationship with the star that gives us life. From this incredible vantage point, the life-giving warmth we take for granted is entirely absent, leaving only a distant, cold beacon in the dark. Plunging deep into this realm, temperatures hover precariously near absolute zero, creating a brutal environment that instantly freezes anything it touches. The biting cold is so profound that familiar substances like water, methane and ammonia are locked into states of rock-hard ice. These are not the delicate melting frosts of Earth, but rather structural materials as dense and unyielding as granite or steel. Surprisingly, the universe reveals an intricate geology born entirely from this extreme thermal deprivation. Mountains thrust upward into the vacuum, composed not of silicate rock, but of deeply frozen water that will never experience the softening touch of a spring thaw. Valleys are carved into plains of solid nitrogen, remaining perfectly preserved in the frigid stillness for billions of years. In this punishing deep freeze, the chemical reactions that drive dynamic change on warmer worlds are brought to an almost complete halt. The relentless cold acts as a cosmic preservative, ensuring that the ancient surfaces remain untouched by anything other than the occasional violent impact from a rogue neighbour. Decades before human technology could pierce the darkness of the outer solar system, Dutch-American astronomer Gerard Kuiper envisioned this icy repository through the sheer power of scientific deduction. He theorized that the edges of the primordial solar nebula could not simply end abruptly, but must gradually fade into a disk of unformed icy debris. His brilliant hypothesis painted a picture of a crowded frontier that remained entirely invisible to the primitive instruments of the mid-20th century. Operating purely on mathematical models and an intuitive understanding of planetary formation, Kuiper argued that Pluto was not a solitary anomaly, but the vanguard of a massive population. He understood that the leftover material from the birth of the giant planets had to be hiding out there in the freezing dark. For many years, his visionary ideas existed solely on chalkboards and in the pages of academic journals, awaiting validation. It is a testament to the power of human intellect that the mind could map a vast region of the cosmos long before the eye could see it. Kuiper's enduring legacy transformed a dark, empty void into one of the most dynamic and populated territories in modern astronomy. Following years of tireless observation, the theoretical finally became real when the first official Kuiper Belt object beyond Pluto was captured by a telescope's lens. Designated as 1992 QB1, this faint smudge of light was discovered only after 5 grueling years of painstaking sky searches by dedicated astronomers. This triumphant moment marked a monumental shift in our understanding of the solar system's true boundaries. Searching for such a tiny, dim object against the overwhelming backdrop of the Milky Way was akin to finding a speck of dust in a raging blizzard. Astronomers had to repeatedly photograph the exact same patches of the night sky, looking for any infinitesimal shift in position among millions of stationary background stars. When that single pixel finally moved, it unlocked the gateway to an entirely new realm of planetary science. The discovery of 1992 QB1 was the spark that ignited a revolution in observational astronomy, proving that the dark spaces were actually teeming with undiscovered worlds. It forever laid to rest the notion of an empty outer solar system, inviting humanity to chart a new and heavily populated frontier. If we were to look closer at the composition of these distant bodies, a striking difference emerges between this frontier and the familiar rocky neighbourhoods closer to the Sun. Unlike the main asteroid belt situated between Mars and Jupiter, which is primarily composed of heavy rock and dense metal, this outer zone is overwhelmingly dominated by volatile ices. The fierce heat of the young sun drove these lighter, easily vaporized materials far out into the frozen edges of the solar disk. Out here, in the permanent chill, molecules that would instantly boil away on Earth are able to condense and accumulate into massive planetary bodies. Carbon monoxide, methane, and nitrogen form a fascinating, shifting crust over cores of solid water ice and primordial dust. This unique chemistry creates a bizarre alien geology that continues to challenge our planetary models. Understanding this chemical divide is crucial to unravelling the complex history of how the solar system initially sorted its materials. The Kuiper Belt stands as the ultimate icy counterpart to the rocky realms of the inner planets, completing the story of our star's chaotic accretion. Contrary to the image of a chaotic, tumbling swarm of debris, the entire belt is actually arranged in a surprisingly ordered and thick disk that aligns roughly with the major planets. This highly structured architecture reveals that the trans-Neptunian region is a natural, continuous extension of the solar system's original protoplanetary disk. The vast majority of these frozen worlds orbit in the same general plane and direction as Earth, bound by the fundamental laws of angular momentum. Within this immense disk, gravitational resonances create distinct neighbourhoods, carving out safe zones and forcing objects into elegant, synchronized orbital pathways. The sheer scale of this flat, spinning ring makes it one of the largest single structures directly bound to the Sun's gravitational authority. It is a masterpiece of celestial mechanics, humming with the quiet, rhythmic precision of a massive clockwork mechanism. Observing the belt's organised shape provides vital clues about the relatively calm conditions that must have prevailed at the very edge of the ancient solar nebula. It stands as a beautifully preserved, rotating fossil of the spinning cloud of gas and dust from which we all eventually emerged. Journeying from the turbulent surface of our star, Light itself must travel for more than 4 relentless hours just to reach the inner edge of this twilight domain. When those exhausted photons finally arrive, they do not scorch the landscape, but instead gently kiss the surfaces of these outer worlds with a weak, silvery illumination. The vastness of the distance dilutes the solar energy so severely that only a ghost of the sun's true power remains to touch the ice. Picture a single beam of light racing past the familiar terrestrial planets, slipping through the asteroid belt and plunging into the deep cold beyond the gas giants. By the time it reflects off a distant crust of frozen methane and begins the long journey back to our telescopes, it has lost almost all of its original intensity. This tremendous delay means that every observation we make of the Kuiper Belt is a look deep into the past. We never see these worlds exactly as they are in the present moment, but only as they were hours ago, cloaked in the fading echoes of sunlight. This temporal lag adds a final layer of profound mystery to a region that continues to guard the most ancient secrets of our cosmic origin. This profound mystery is perhaps most deeply guarded by Pluto, the undisputed king of this cold and distant realm. Once considered a simple, dead ball of ice at the edge of the solar system, it was revealed by the New Horizons probe to be a world of staggering geological complexity. Far from being a static, cratered relic, its surface is a dynamic tapestry of towering ice mountains, smooth plains, and strange, blade-like terrains. Notice how the smooth, heart-shaped plains of solid nitrogen known as Sputnik Planitia dominate the landscape, surprisingly devoid of impact craters. This vast, bright feature suggests that the surface is actively churning, constantly refreshing itself from below and erasing the scars of ancient cosmic collisions. It is a slow, freezing convection process, driven by faint internal heat that belies the planet's diminutive size and immense distance from the sun. As you consider this hidden warmth, allow a soft, deep breath to expand your chest, feeling the steady rhythm of your own internal engine. Let your shoulders drop an inch lower, releasing any tension into the solid support beneath you. Slightly smaller than the former 9th planet, but possessing a significantly greater mass, Eris commands its own unique presence in the dark. It gleams with an intense, almost blinding brightness, reflecting the meagre sunlight far more efficiently than its neighbours. This brilliant reflectivity is due to a fresh, pristine coating of frozen methane that periodically falls from its temporary freezing atmosphere like cosmic snow. When this massive dwarf planet travels furthest from the Sun on its highly elliptical orbit, its thin atmosphere completely collapses and freezes onto the surface. This creates a blindingly white, untouched shell of volatile ice that masks the darker, older materials lying beneath. As it slowly swings back toward the inner solar system over hundreds of years, the process will eventually reverse, releasing the methane back into a tenuous gaseous halo. The sheer density of Eris forced astronomers to fundamentally reconsider what it means to be a planet, sparking a reclassification that changed textbooks forever. It stands as a heavy, shining beacon, proving that significant mass and complex behaviour are not limited to the inner solar system. Strangely shaped Haumea challenges our conventional expectations of planetary forms, resembling a flattened cosmic football rather than a perfect sphere. This bizarre elongation is the direct result of an incredibly rapid rotation, with the entire world completing a full spin in less than 4 hours. The sheer centrifugal force generated by this frantic twirling has literally stretched the dwarf planet outward at its equator, fighting against its own gravity. If we were to look closer, we would see that this rapid spin is likely the lingering scar of a catastrophic, ancient collision. Billions of years ago, a massive impact not only set Haumea spinning wildly, but also shattered its icy mantle, creating a family of smaller related fragments that still share similar orbits today. This violent birth story is written into the very shape of the world, a permanent record of the chaotic early days of the outer solar system. Its surface is remarkably bright, composed almost entirely of pure crystalline water ice that reflects the distant starlight with stunning clarity. This pristine composition is unusual, suggesting a complex history of melting, refreezing, and perhaps ongoing resurfacing mechanisms that we do not yet fully understand. Allow your mind to drift away from these violent cosmic collisions, settling instead into the quiet stillness of your own resting body. Notice the gentle weight of your hands, heavy and relaxed, completely supported as you continue this journey through the dark. Makemake presents a different kind of frozen puzzle, lacking the complex atmosphere of Pluto despite being of a similar size and composition. Instead of a smooth, churning plain or a collapsing atmospheric shell, its surface is covered in coarse pellets of frozen methane as large as hailstones. These rugged, icy chunks scatter the faint light, giving the dwarf planet a reddish-brown hue that distinguishes it from the brighter, whiter objects nearby. This static, frozen landscape provides a crucial baseline for scientists, offering a counterpoint to the surprisingly active terrains found on some of its peers. It is a quiet, steady world, silently preserving its chemical makeup without the dramatic geological resurfacing seen elsewhere. Notice the distinct reddish-brown tint of Quaoar, a massive body that hints at a history far more dynamic than its current frozen state suggests. This coloration is a telltale sign of complex organic compounds, baked into the surface by eons of exposure to harsh cosmic radiation. Yet, amidst this ancient irradiated crust, there are signs of something unexpected. Patches of crystalline water ice that should have long since degraded. The presence of this fragile crystalline structure implies that the ice was relatively recently exposed or erupted onto the surface, shielding it from the degrading effects of radiation. This points toward the possibility of ancient cryovolcanism, where slushy mixtures of water and ammonia may have once erupted like cold lava from the interior. Even out here, in the deepest cold, geological death is not always absolute, and sparks of internal activity may have briefly illuminated the dark. Such discoveries blur the line between dead rocks and active worlds, forcing us to re-evaluate the thermal histories of these distant objects. Quaoar stands as a silent witness to a time when even the coldest corners of the solar system possessed a fleeting hidden warmth. Feel the slow, steady rhythm of your breathing, a reassuring constant as we venture further into the strange and unpredictable orbits of the outer solar system. Let the quiet darkness behind your closed eyes mirror the vast, empty spaces between these lonely worlds. Sedna wanders on a trajectory so extreme and highly elliptical that it defies the neat, organised structure of the main disk entirely. Its orbit takes it far beyond the gravitational influence of Neptune, plunging deep into the mysterious, uncharted territory known as the Inner Oort Cloud. A single year on this solitary world lasts over 11,000 Earth years, meaning it spends the vast majority of its existence in profound, unimaginable isolation. The very existence of Sedna is a celestial paradox, as it never comes close enough to the giant planets to have been scattered outward by their gravity, nor does it venture far enough to be considered a true interstellar wanderer. Its peculiar path suggests that it was violently pulled from its original orbit by a passing star, or perhaps an unseen, massive companion lurking in the distant dark. It is a gravitational fossil, carrying the signature of an ancient, unknown encounter that forever altered its destiny. Its deep red colour is among the most intense in the solar system, a thick layer of organic sludge that has never been disturbed by the warmth of a close solar approach. Sedna is a true exile, a world that belongs neither to the familiar planetary family nor to the deep interstellar void. Orcus, often described as the anti-Pluto, mirrors the orbit of its more famous sibling with uncanny precision, yet the two are destined never to meet. While they share the same gravitational resonance with Neptune, completing 2 orbits for every 3 of the ice giant, they are locked in a celestial dance that keeps them on opposite sides of the solar system. When one world approaches the sun, the other is at its most distant, maintaining an eternal balancing act across the vastness of space. This precise orbital symmetry is a testament to the powerful invisible hand of Neptune, which dictates the movements of thousands of objects in this region. Despite their similar sizes and orbital paths, Orcus appears to have a very different surface composition, showing abundant signs of crystalline water ice and perhaps even ammonia. It lacks the dramatic, active nitrogen planes of its twin, suggesting a divergent evolutionary path despite their shared gravitational constraints. Studying Orcus provides a crucial comparison point, helping scientists understand how two worlds with nearly identical orbits can evolve into such vastly different environments. It is a quiet reflection, a parallel reality playing out in the dark, separated from its twin by billions of miles of empty space. As we trace these intricate mirrored paths, allow your mind to find its own quiet centre of gravity, a place of stillness amidst the complex motions of the universe. Take a moment to simply be present, feeling the solid ground beneath you, anchoring you in the here and now. Salacia shares its orbital space with a multitude of smaller fragments, quietly reflecting the faint starlight without the dramatic features of its larger neighbours. It is a massive, dark world, lacking the bright, volatile ices that make bodies like Eris or Pluto stand out against the black backdrop of space. Instead, its surface is likely a mixture of ancient water ice and dark organic materials, absorbing much of the weak sunlight that manages to reach it. Despite its subdued appearance, Salacia is not alone, accompanied by a surprisingly large moon named Actea. The presence of this sizable companion suggests that, like many large bodies in this region, Salacia experienced a violent collision in its past that spun off a significant portion of its mass. These dark, silent pairs are common out here, locked in mutual orbits that tell tales of a crowded, chaotic early history. It is a world that commands no headlines, quietly enduring the eons in the freezing shadows, a typical, unassuming member of a vast frozen population. Yet, even in its obscurity, Salacia holds valuable clues about the bulk composition and collisional history of the outer solar system. Vada and its moon Ilmar dance in a tight, inseparable embrace, revealing the complex gravitational interactions that govern these dwarf planetary systems. They orbit each other so closely that their mutual gravity significantly distorts their shapes, pulling them into elongated forms that continuously tug at one another. This intimate waltz generates internal friction, potentially keeping their interiors slightly warmer than their completely isolated neighbours. The intricate dynamics of such close binaries challenge our models of how moons form and evolve in the deep freeze of the outer solar system. It is a delicate balance of orbital mechanics, where the slightest perturbation could send them spiralling together or flinging them apart into the void. Their shared centre of mass traces a smooth, predictable path around the Sun, while the two bodies themselves tumble and spin in a complex, chaotic ballet. These paired worlds demonstrate that the outer solar system is not just a collection of solitary rocks, but a dynamic, interacting environment where gravity weaves intricate relationships. They are bound together by an invisible thread, traversing the lonely dark as a unified system. Ultimately, what distinguishes these kings of the cold from the countless smaller fragments is that they hold enough mass to have pulled themselves into rounded shapes under their own gravity. This crucial milestone, the achievement of hydrostatic equilibrium, is the defining characteristic that separates true dwarf planets from mere rubble. It requires a tremendous amount of material, crushing the internal structure under its own weight until the jagged edges of a primordial asteroid are smoothed into a sphere. This process of rounding implies that, at least for a brief period in their history, the interiors of these massive bodies must have been warm and malleable enough to flow like thick liquid. The heat generated by radioactive decay and the violent energy of their formation allowed gravity to sculpt them into the familiar planetary shapes we recognize. They are the successful survivors of the accretion process, the largest building blocks that managed to gather enough mass to impose order upon themselves. They stand as the heavyweights of the outer dark, silent, spherical monuments, presiding over a vast kingdom of scattered ice and dust. Presiding over this scattered kingdom is Neptune, acting not as a static boundary, but as the grand, dynamic conductor of an icy orchestra. Its massive gravitational influence reaches far beyond its own physical location, dictating the precise, metronomic orbits of thousands of distant objects. Every subtle shift in the ice giant's path sends invisible ripples through the dark, corralling these tiny frozen worlds into highly organized mathematical patterns. Consider the sheer power required to impose such order across billions of miles of empty space. Neptune does not physically touch these bodies. Instead, it catches them in a web of gravitational resonance, a delicate interplay of orbital speeds that locks them into a perpetual synchronized rhythm. This distant, sweeping tide is the fundamental force that sculpts the architecture of the outer solar system, transforming a chaotic scattering into a structured system. By mapping these resonant patterns, astronomers can essentially track the invisible currents of gravity that flow outward from the ice giant. It is a masterful display of celestial mechanics, where the invisible mass of a single planet commands the movements of a vast frozen frontier. A fascinating result of this orchestration is the existence of a special group of objects known as Plutinos, which are locked into a precise orbital ratio with their conductor. For every 3 complete trips Neptune makes around the Sun, these resonant bodies complete exactly 2, creating a stable, repeating pattern that endures for billions of years. This 2 to 3 resonance is a mathematical safe harbour in the turbulent gravitational waters of the outer solar system. These objects are essentially surfing on the leading and trailing edges of Neptune's gravitational waves, perpetually pushed along in a synchronized dance. Because their orbital periods are locked together, the geometry of their paths never allows them to come close enough to the giant planet to be scattered or absorbed. They are intimately tied to their massive neighbour, yet forever kept at a safe, predictable distance by the very forces that bind them. This elegant lockstep movement highlights the hidden structure that exists even in the most remote regions of our star system. It reveals a level of organisation and stability that is completely invisible to the naked eye. As you reflect on these steady, repeating orbits, allow your own body to sink a little deeper into its resting place. Notice the rhythmic rise and fall of your chest, a quiet internal resonance that grounds you in the present moment. This delicate gravitational dance is crucial, as it physically prevents these bodies from ever colliding with the massive ice giant that dictates their paths. If a Plutino were to stray even slightly from this precise 2 to 3 ratio, the immense pull of Neptune would quickly destabilize its orbit, leading to a catastrophic collision or an aggressive ejection into deep space. The resonance acts as an invisible shield, a protective mechanism that guarantees the long-term survival of these small icy worlds. The sheer longevity of this arrangement is astounding, as many of these objects have likely maintained this delicate balance since the very early days of the solar system. Their continued existence is proof that this complex orbital choreography is not a temporary fluke, but a highly stable fundamental feature of celestial mechanics. They have successfully navigated a dangerous gravitational minefield by finding the perfect repeating rhythm. It is a testament to the elegant self-correcting nature of orbital dynamics, where massive forces ultimately find a sustainable balance over cosmic timescales. The dark is not a place of random collisions, but a highly structured environment defined by invisible boundaries. Two Tinos follow a slightly different, but equally precise rhythm, circling the Sun exactly once for every 2 orbits completed by their blue conductor. This 1 to 2 resonance places them significantly further out in the disk, defining the outer edge of this specific, highly structured orbital family. Like their closer cousins, they are locked in a perpetual, stabilizing waltz, their long, slow years dictated by the distant sweep of the ice giant. These objects spend the vast majority of their time at the very edge of the Sun's gravitational reach, only briefly sweeping inward before being pulled back out into the deep freeze. Their elongated orbits are a direct result of the resonant forces that hold them, stretching their paths into vast elliptical loops that take hundreds of Earth years to complete. They mark the boundary where the organised, resonant structures begin to give way to the more chaotic, distant populations. Observing the Tutinos provides essential data on the outer limits of planetary influence, showing how far a single giant's gravity can effectively reach an organised material. They are the final distant notes in the grand symphony orchestrated by Neptune. Allow your mind to relax, stepping back from these complex mathematical relationships and simply observing the quiet dark behind your closed eyes. Feel the comfortable weight of your limbs, completely supported and at ease as the journey continues. Picture the classical objects, or cubawanos, floating serenely in nearly circular orbits, seemingly completely unaffected by the sweeping planetary gravity that organizes the resonant populations. They inhabit a wide, stable region between the different resonant zones, representing the calm, undisturbed core of the outer icy disk. These are the true, untouched remnants of the original protoplanetary nebula, continuing on the simple, circular paths they have followed since their initial formation. Because they are free from the destabilizing tugs of the giant planets, their orbits are remarkably flat and orderly, tightly aligned with the general plane of the solar system. They have never been subjected to the violent scattering or the strict forced rhythms that define the lives of their neighbours. Their serene, undisturbed existence makes them the most pristine, unaltered samples of primordial material available for study. This classical population provides a crucial baseline, a glimpse into what the entire outer solar system might have looked like before the giant planets began to migrate and disrupt the region. They are the quiet, unchanging foundation upon which the rest of this complex architecture is built. The scattered disk, in stark contrast, contains eccentric wanderers that were violently flung outward by Neptune billions of years ago during a period of intense planetary migration. These objects possess wild, highly elliptical orbits that are often steeply inclined to the plane of the solar system, diving in close to the sun before soaring out into the extreme distances. They are the casualties of a chaotic past, survivors of a time when the giant planets were aggressively rearranging their positions and clearing their neighbourhoods of debris. When Neptune pushed outward into the primordial disk of ice, its massive gravity acted like a cosmic plough, scattering countless small bodies in all directions. While many were thrown inward or ejected from the solar system entirely, the scattered disk objects were hurled into these long-stretched orbits where they remain today. They are physical evidence of a violent history, their chaotic paths recording the sheer force of planetary migration. Studying these scattered bodies helps astronomers reconstruct the precise timeline and mechanics of how the giant planets reach their current stable configurations. They are the dynamic, unpredictable counterparts to the serene classical population. These scattered objects effectively form the true dynamic boundary of the solar system, reaching out to incredible distances that dwarf the neat, organised structure of the main disk. Their elongated orbits can take them hundreds of times further from the Sun than Earth, venturing deep into the interstellar medium where the solar wind begins to fail. They represent a transition zone, the jagged edge where the Sun's gravitational authority slowly fades into the background noise of the galaxy. At their most distant points, these icy wanderers move incredibly slowly, suspended in a deep freeze that is barely touched by the Sun's heat or light. They spend the vast majority of their extremely long orbits in this profound isolation, only accelerating briefly as they dive back toward the inner solar system. They are the scouts of our planetary family, pushing the limits of what we consider to be gravitationally bound to our star. This distant, scattered population bridges the gap between the structured outer solar system and the mysterious, unseen depths of the Oort cloud. They are the physical link to the true cosmic frontier. Once again, draw your attention back to your resting body, taking a slow, calming breath and feeling the solid, grounding presence of the surface beneath you. Let go of any lingering tension, allowing yourself to simply observe the vastness of the cosmos from a place of comfort and stillness. Resonant objects demonstrate clearly that the early solar system was not always a peaceful, organised place, but rather a chaotic environment where giant planets migrated significantly. If Neptune had formed exactly where it is today, it could not have captured so many objects into such precise, varied resonant orbits. The current architecture requires that the ice giant must have slowly, inexorably ploughed outward through the primordial disk of ice, pushing the smaller bodies ahead of it. This migration theory fundamentally changed our understanding of planetary formation, replacing the idea of static, unchanging orbits with a dynamic, evolving model. As Neptune moved outward, its sweeping gravitational resonances acted like a series of moving snowplows, gathering up material and forcing it into these stable, synchronized patterns. The exact distribution of these resonant objects allows scientists to calculate exactly how far and how fast the giant planet must have travelled. It is a stunning realization that the neat, clockwork precision we observe today was born from a period of profound instability and movement. The current order is simply the aftermath of a massive system-wide reorganization. The sweeping motion of Neptune captured smaller bodies into these stable gravitational pockets over millions of years, slowly building the complex architecture we see today. It was not a sudden, violent event, but a gradual, relentless process of gravitational sorting and sifting. As the ice giant migrated, its resonant zones moved with it, sweeping across the disk and gently nudging objects into alignment. Once an object was caught in a resonance, it was dragged outward along with the migrating planet, its orbit expanding while maintaining the precise mathematical relationship. This careful, synchronized pushing explains why we find such large populations of objects locked into these specific orbital pathways. It is a process of celestial shepherding, where the massive planet slowly gathered its icy flock over unimaginable stretches of time. This gradual capture mechanism highlights the subtle, long-term power of gravity to organize and structure an entire region of space. It is a slow, methodical process of creation out of chaos. Today, this intricate architecture provides a pristine fossil record of how the giant planets rearranged themselves in the deep past. By carefully mapping the distribution of the classical, scattered and resonant populations, astronomers can run the clock backward, modelling the precise movements that must have occurred to create the current arrangement. The outer solar system is essentially a complex gravitational puzzle that, when solved, reveals the violent history of our origins. Every discovered object, with its unique orbital path and chemical signature, adds a crucial piece to this grand historical reconstruction. We're not just cataloguing rocks, we're reading the history of our planetary family, written in the slow, silent movements of ice in the dark. The orbits themselves are the undeniable proof of a dynamic, ever-changing universe. It is a profound realization that the key to understanding the violent birth of the inner planets lies hidden in the quiet, frozen movements of the most distant frontier. Deep within this distant frontier, the silence is painted in a hue of deep, rust red by bizarre compounds known as tholins. These complex organic molecules are the result of a slow, chemical alchemy performed by the universe itself over vast spans of time. When the sun's faint ultraviolet rays finally reach these icy surfaces, they strike simple molecules like methane and ethane, forging them into a reddish, sticky residue that clings to every jagged peak and frozen crater. As you absorb the image of this rust-coloured dust, allow your shoulders to drop and your breathing to find a natural, effortless cadence. Let the quiet of the room mirror the stillness of the outer belt, grounding you in the present moment. This cosmic paint does not wash away. Instead, it accumulates in a thick, velvety layer that masks the brilliant white of the underlying ices. It is a slow-motion transformation, a silent dialogue between light and ice that has been occurring since the planets first settled into their current paths. The resulting shades range from a pale, dusty amber to a deep, wine-dark crimson, giving each world a unique visual identity in the twilight. These organic dustings are the physical fingerprints of time, marking surfaces that have sat undisturbed for billions of years. This structure is home to an organic tar that does not exist naturally on the modern Earth, requiring the harsh conditions of the deep freeze to remain stable. While our own world is defined by liquid water and a thick protective atmosphere, the outer solar system relies on a different chemistry altogether. In the vacuum of the Kuiper Belt, these heavy molecules can settle and harden without being broken down by oxygen or moisture. On Earth, such complex organic structures would be quickly consumed by life or degraded by geological processes, yet here they find a permanent sanctuary. They are the artifacts of a primitive chemistry that has remained unchanged since the solar nebula began to collapse. This makes the outer reaches a unique chemical laboratory, where the heavy tar-like substances form the very foundation of the visible landscape. Arakoth, a snowman-shaped contact binary drifting in the deep dark, displays a striking red hue that serves as a testament to millions of years of radiation exposure. This peculiar object is formed from two distinct lobes that gently touched and fused together in a slow-motion embrace billions of years ago. Its surface is remarkably uniform in its deep crimson colour, indicating that it has remained in a state of nearly perfect preservation since its birth. The intensity of its colour provides a chronological map of its history, showing exactly how long it has been bombarded by the relentless stream of cosmic rays. Because Arakoth is a cold classical object, it has never been pushed closer to the sun, meaning its tholins have never been baked away or buried by atmospheric activity. It is a pristine, frozen witness to the ancient conditions of the solar system's edge. Surprisingly, the universe reveals that the colour variations across the belt tell a complex story about where each individual object originally formed. While some bodies gleam with a pale, neutral grey, others are saturated with the deep reds of ancient tholins. These differences act as a geographical map, revealing the chaotic movements that shuffled the outer solar system during its infancy. As you contemplate this vast spectrum of colour, feel the subtle weight of your body pressing into the seat, a solid anchor amidst the shifting hues of the void. Take a moment to breathe into the stillness, allowing your focus to sharpen on the incredible diversity hidden within the dark. Every shade of amber, rust, and grey represents a different chemical path taken through the turning of the ages. The objects with the reddest surfaces likely spent their entire lives in the most distant reaches, where radiation could work its magic without interruption. Conversely, the more neutral-coloured bodies may have been born closer to the sun before being flung outward by the giant planets, their original compositions altered by the heat. By reading these colours, astronomers can trace the long-lost origins of bodies that now appear to be neighbours. Detailed chemical analysis reveals that objects formed closer to the sun tend to possess fundamentally different chemical compositions than those born in the deepest cold. In the warmer regions of the early solar nebula, volatile substances like methane and carbon monoxide were unable to settle, leaving behind mostly water ice and silicate dust. As a result, these inner-born objects lack the rich organic coatings that define the more distant residents of the belt. When we examine a world that appears grey or white, we're likely looking at an immigrant from a warmer era, a traveller that has been displaced from its birthplace. The deep red objects, by contrast, are the true natives of the deep freeze, composed of the volatile ices that could only condense in the most extreme shadows. This chemical sorting is a permanent record of the temperature gradients that existed billions of years ago. This distinction allows scientists to categorize the belt's population not just by their current orbits, but by their chemical lineage. It highlights the fact that the Kuiper Belt is a melting pot of different histories, bringing together worlds from across the entire outer solar system. The chemistry of each object is its birth certificate, revealing the specific temperature of the cloud from which it emerged. Imagine a landscape where water ice acts as the bedrock, harder than granite and frozen into jagged cliffs that will never experience the softening touch of warmth. Over millions of years, this frozen foundation has been gently dusted with a fine organic red snow composed of tholins settling out of the vacuum. This creates a scenery of stark, beautiful contrasts, where the deep wine-coloured dust gathers in the crevices of blue-white glaciers. Walking across such a surface would feel like traversing a desert of frozen glass, with every footstep crunching through the brittle organic coating. The stillness of these plains is absolute, a frozen wilderness where the only movement is the slow drift of the stars overhead. It is a place where the concepts of geography and weather are redefined by the extreme limits of cold. If we were to look closer, we would see that even in this deep freeze, a strange and subtle cycle of change persists as methane and carbon monoxide ice shift between solid and gas. During the long, eccentric orbits of these bodies, the tiny increase in heat during a close approach to the sun can be enough to trigger a slow sublimation. This process allows the most volatile ices to migrate across the surface, moving from the sun-drenched peaks to the permanently shadowed valleys. As you imagine this invisible breath of gas rising from the surface, feel the cool air entering your own lungs, a soft and steady reminder of your own vitality. Let the breath move in and out without effort, just as the ices shift and settle over centuries. This seasonal rhythm plays out over decades and centuries, a slow heartbeat of expansion and contraction. When the object swings back into the outer dark, these gases settle once more, forming a fresh, sparkling frost that covers the older layers of tholin. These phase shifts are responsible for the complex layering seen on worlds like Pluto, where different types of ice compete for space. The landscape is not static, but slowly breathing, constantly rearranging its frozen components in response to the sun's distant tug. The lack of an atmosphere on most objects means that space weathering can directly alter surface chemistry over eons. Without air to filter out the sun's radiation, or the impact of the microscopic dust particles, the top layers of these worlds are constantly being reshaped. Every photon and high-speed particle that strikes the ice leaves a chemical scar, slowly darkening and reddening the pristine material. This process, known as solar wind tanning, ensures that the oldest surfaces are often the most saturated in colour. It is a form of cosmic aging, a visible clock that records the passage of billions of years in the deep dark. The resulting crust is often porous and brittle, a fragile shell that protects the ancient unweathered ice lying just centimetres beneath the surface. This interaction between the vacuum of space and the frozen ground is the primary engine of change in a region where there are no rivers or winds. It is a slow-motion erosion, carving the chemistry of the world through the sheer persistence of radiation. It transforms simple molecules into the complex, dark polymers that give the belt its characteristic and mysterious look. Notice the startlingly bright, fresh ice patches where recent impacts have punched through the dark crust and exposed unweathered material from underneath. These luminous scars stand out against the deep red background like beacons, revealing the brilliant, clean water ice that forms the core of these objects. It is a sudden, violent injection of light into a landscape that has been darkening for millions of years. As you envision these brilliant flashes of white against the rust-red plains, allow your shoulders to soften even further, feeling a deep sense of calm settle over your frame. Let the weight of your body be fully claimed by the stillness as we observe these rare moments of cosmic renewal. These impact sites provide a unique opportunity for astronomers to peer beneath the tholin-covered veil and see the true composition of the belt's residents. They act as natural drill sites, bringing the hidden history of the interior up to the surface for all to see. Over time, even these bright patches will eventually darken as the space weathering begins its work once again. But for a brief cosmic moment, they represent the pristine state of the early solar system. It is a reminder that beauty can emerge from the most violent of encounters. These primitive organic molecules are thought to be the chemical precursors to the very building blocks of life. Deep within these gardens of tholin, the universe has stored complex chains of carbon, hydrogen, and nitrogen that eventually rain down upon the young Earth. The Kuiper Belt is essentially a vast frozen pharmacy, preserving the ingredients for life in a state of perfect stasis for billions of years. While these icy worlds themselves are too cold to support life as we know it, they act as the ultimate reservoir for the materials that make life possible elsewhere. Every comet that leaves this region carries with it a cargo of these precious organic compounds, ready to be delivered to warmer, more hospitable worlds. It is a profound realization that our own existence may be fundamentally linked to the chemistry of this remote frozen frontier. The same red dust that paints the surface of ancient objects may be the ancestor of the organic molecules in our own bodies. In this way, the outer solar system is not an end, but a beginning, a source of potential that stretches across the vastness of space. It is the silent, icy cradle of a much larger and more vibrant cosmic story. This vibrant cosmic story often begins with a subtle, invisible shift in the deep dark, as the Kuiper Belt transforms from a silent repository into the primary source of short-period comets. These wanderers, which take fewer than 200 years to complete their circuit around the Sun, are the primary messengers between the outer wilderness and our inner world. They represent a dynamic link, a physical bridge across the billions of miles of vacuum that separate the familiar planets from the icy frontier. Deep within this reservoir, trillions of potential comets wait in a state of suspended animation, frozen solid and shrouded in the twilight of the outer system. They are the quiet architects of the night sky, holding the potential to become the brilliant streaking visitors that have inspired awe and terror throughout human history. This reservoir is not just a collection of debris, but a vast sleeping garden of ice, capable of sending its children on long, perilous journeys toward the center of the system. When we see a comet gracing the horizon of Earth, we are witnessing an emissary from this distant realm, a piece of the deep freeze that has finally escaped its ancient home. It is a profound realization that the celestial displays we admire are born in the profound stillness of the trans-Neptunian dark. The Kuiper Belt is the ultimate nursery, nurturing these icy spirits for billions of years before releasing them into the light. The journey inward is rarely an accident, often beginning when a scattered disk object gets nudged by a delicate gravitational whisper. In the complex orbital mechanics of the outer system, even a tiny shift in position can have monumental consequences over cosmic timescales. A passing body or a subtle resonance with a giant planet can provide just enough momentum to break the ancient bonds of a circular orbit. If we were to look closer at this process, we would see a slow-motion fall that takes thousands of years to gain true speed. This gravitational nudge acts like a gentle push on a playground swing, slowly increasing the eccentricity of the object's path until it begins to dive toward the Sun. It is a transition from a stable, predictable existence into a chaotic, high-stakes descent through the domains of the gas giants. As you imagine this long, silent fall through the void, allow your breathing to remain slow and effortless, a steady anchor for your mind as it wanders the outer dark. Feel the calm weight of your body, perfectly safe and supported, while these icy wanderers embark on their precarious travels. This nudge is the catalyst for change, the moment the potential energy of the outer belt is converted into the kinetic energy of a comet's path. Surprisingly, the true transformation of these wanderers begins only when they cross the invisible threshold of Jupiter's orbit. At this distance, the Sun's influence finally becomes strong enough to overcome the crushing cold of the outer system. This is the moment the comet truly wakes up, as the increasing heat triggers a sudden, violent eruption of ancient gases. A sudden geyser of sublimating ice erupts into the void, a spectacular spray of vaporized water, carbon dioxide and ammonia that had been trapped for eons. The rock-hard surface, which remained stable for billions of years in the Kuiper Belt, begins to crumble and hiss as the ices turn directly into gas. This dramatic release of energy is the sensory heart of the comet's life cycle, a thermal awakening in the vacuum. Feel the gentle rise of your own chest, a rhythmic movement that mirrors the quiet expansion of these icy gases into the dark. As the geysers bloom, the object is no longer a dark, invisible rock, but a living, breathing entity interacting with the solar wind. This sublimation is the engine of the comet's beauty, a fierce and fragile defiance of the deep freeze it once called home. This structure of gas and dust soon expands into a spectacular glowing coma, a spherical halo that can grow larger than a planet. As the comet continues its dive toward the Sun, the solar wind pushes these liberated particles away from the nucleus, forming the iconic tails that stretch for millions of miles. These luminous ribbons of light are composed of ionized gases and tiny dust grains, reflecting the Sun's power with haunting brilliance. Imagine a tail so vast that it sweeps across the orbits of several planets, a ghostly veil of material that was once locked in the trans-Neptunian shadows. The dust tail glows with a soft yellowish light, while the gas tail often appears as a striking electric blue. These features the visual climax of the journey, a brief and glorious moment of visibility for a body that spent billions of years in obscurity. For millennia, these displays have fascinated humanity, serving as omens, portents, and now as invaluable scientific windows into our past. They are the most visible evidence of the Kuiper Belt's reach, bringing the material of the outer disk into the direct gaze of those who look at the stars. Every glowing tail is a signature of the deep dark, written in light across the inner solar system. Notice, however, that not all famous visitors share the same birthplace, as Halley's Comet serves as a prominent and fascinating exception to the rule. While many short-period comets hail from the Kuiper Belt, Halley is likely an immigrant from the even more distant and mysterious Oort cloud. Its path is far more elongated and eccentric, suggesting it was cast out from a much deeper, spherical reservoir of ice that surrounds the entire solar system. This distinction highlights the incredible diversity of the comet populations and the different reservoirs that feed them. While the Kuiper Belt is a flat disk, the Oort cloud is a gargantuan sphere, and their different geometries create comets with very different orbital characteristics. Halley's presence is a reminder that the Sun's gravitational influence extends far beyond the icy ring we are exploring, reaching into an abyss we have yet to truly map. As you consider the vast distances between these different homes, feel the steady support beneath you, a fixed point in a universe of moving ice. Let your mind rest in the knowledge that even the most famous wanderers have distinct lineages, each telling a different story of the early solar system's architecture. Halley is a lonely traveller from the outermost edge, a guest from the true deep. If we were to look closer at the comets that visit most frequently, we would find that the Jupiter family comets are almost entirely escapees from the trans-Neptunian reservoir. These bodies have been captured by the gravity of the largest planet, which has shortened their orbits until they are trapped in a cycle of frequent solar encounters. They are the permanent residents of the inner system, their lives dictated by the massive blue-banded giant that redirected their paths. Once a scattered disk object enters the inner system, Jupiter acts as a gravitational gatekeeper, either flinging the intruder away or pulling it into a stable, shorter orbit. This capture process transforms a long-period wanderer into a frequent visitor, ensuring that the inner solar system is never truly empty of icy guests. These comets are the most heavily studied, as their predictable returns allow us to plan missions to encounter them directly. Their proximity to the Sun means they age much faster than their distant cousins, losing their volatile ices with each passing circuit. They are the weary travellers of the comet world, their surfaces becoming darkened and scarred by the heat. Despite their wear, they remain the most accessible links we have to the primordial material of the Kuiper Belt. This erosion is ultimately a terminal process, as every comet that eventually burns up or crashes into a planet is a piece of the original Kuiper Belt that is lost forever. When a comet's volatile supply is exhausted, it becomes a dormant dark rock, essentially a dead comet that no longer displays a glowing tail. Some meet a more violent end, plunged into the Sun's fiery atmosphere or obliterated by an impact with a planet like Jupiter. This process of depletion is one of the ways the solar system continues to evolve, even long after its initial birth. The comets we see today are the survivors of a much larger population that has been slowly dwindling since the beginning of time. Each impact is a fragment of the ancient past being permanently recycled into the fabric of the modern planets. Deep within the belt, however, the supply remains staggering, as the region must contain billions of these dormant comets, just waiting for a gravitational push. For every one comet that enters the inner solar system, there are millions more that remain tucked away in the deep freeze, undisturbed and invisible. This vast, silent army of ice represents the potential for future displays of celestial beauty that will play out over the next several billion years. The sheer scale of this population is difficult to fathom, a massive treasury of material that has remained largely intact since the formation of the Sun. It is a dormant wilderness, a place where the pace of change is measured in eons rather than years. These objects are not yet comets. They are planetesimals, the building blocks of worlds that never quite finish the job. As you breathe into the stillness of your own space, imagine this near-infinite collection of frozen hearts, each one a potential star of the night sky. They are the silent witnesses of the outer disk, a reservoir of wonder that ensures the story of the comets will continue for as long as the sun continues to shine. The nursery is never truly empty. It is simply waiting for the next invisible ripple of gravity to wake its children. Surprisingly, the universe has provided us with a shortcut to history, as studying a comet up close is like examining a pristine sample of the Kuiper Belt without ever leaving the inner solar system. Because these bodies spend the vast majority of their lives in the deep freeze, their interiors remain cold and untouched by solar radiation. When they finally dive inward, they bring the 100% original chemistry of the early solar nebula directly to our doorstep. Shutterstock. The dust and gas released by a comet are essentially a time capsule, carrying the specific molecules and isotopes that were present when the planets were first forming. By flying spacecraft through the tails or landing on the nuclei, we can sample the ancient ices and organic compounds that would otherwise be out of reach. It is a scientific miracle of convenience, a way to touch the farthest edges of the system from the comfort of our own planetary neighbourhood. Every piece of data gathered from a comet's coma is a piece of the Kuiper Belt puzzle, revealing the temperature, pressure and chemical makeup of our birth. They are the messengers of our origins, delivering the secrets of the deep dark into the hands of modern science. Through them, we're able to reconstruct the history of the entire system, one frozen grain of dust at a time. Eventually, this supply of comets will slowly deplete as the belt loses its smallest members to the gravitational pull of the giant planets. The Kuiper Belt is not an infinite resource, and the processes that send comets our way are also the processes that are gradually emptying the reservoir. Over tens of billions of years, the density of the belt will fade, and the frequency of spectacular cometary visitors will naturally decline. We are living in an era where the belt is still relatively populated, allowing us to witness the last great gasp of the solar system's formative material. As the giant planets continue their slow gravitational dance, they will continue to sift through the icy debris, flinging the smallest fragments into the abyss. The architecture of the belt is slowly dissolving, a long-term erosion that will eventually leave the outer system as empty as the spaces between the stars. In this vast, dissolving architecture where the smallest fragments are flung into the abyss, a surprising resilience emerges among the larger survivors of the belt. While the lesser debris is sifted away by the gravitational winds of the giants, the most massive icy worlds have managed to gather and hold on to companions in the deep dark. Nearly all of the largest residents in this remote realm possess at least one moon, a silent partner locked in a permanent orbital embrace. This cosmic companionship transforms our perception of the outer system from a graveyard of lonely rocks into a bustling theatre of interacting worlds. These satellites are not merely accidental captures, they are integral parts of the identity of their hosts, moving together through the void as unified systems. To look upon a major trans-Neptunian object is to witness a shared journey, where the gravity of one provides the anchor for the other's existence. These moons vary wildly in size and distance, some clinging tightly to their parents, while others wander on long looping paths that graze the very edge of their gravitational influence. Together, they form a hidden census of the belt's complexity, proving that even in the most desolate reaches of space, isolation is the exception rather than the rule. Surprisingly, the universe has placed its most intricate satellite system around the most famous of these icy kings, where Pluto hosts an entire family of 5 diverse moons. The largest of these, Charon, is so massive in proportion to its primary that the two do not merely exist as a planet and its satellite, but as a true binary dwarf planet system. They orbit a common centre of gravity that actually lies in the empty space between them, forever circling a point that belongs to neither. This gravitational lock is so absolute that both worlds are tidally locked, meaning they always show the same face to one another as they spin through the dark. The barycenter, or the balance point of their mutual dance, sits well above Pluto's surface, making them a unique pair in our solar neighbourhood. Beyond this central duo, 4 smaller, jagged moons, Styx, Nix, Kerberos and Hydra, dance in a chaotic and complex resonance further out. This entire system operates like a miniature solar system, a clockwork arrangement of ice and rock that has remained stable for eons. The presence of such a diverse family suggests a history of profound interaction, where the gravitational tides of the larger pair have carefully organised the paths of the smaller siblings. Haumea presents a different kind of architectural wonder, circled not only by 2 icy moons but also by a thin, delicate system of rings. This unique arrangement is thought to be the debris from a catastrophic ancient collision, a trauma so intense it shattered the world's outer layers and sent a cloud of icy shrapnel into orbit. The 2 moons, Hiaka and Namaka, are likely the largest survivors of this event, named for the mythological daughters of the Hawaiian goddess of the earth. The rings themselves were a startling discovery, proving that even small, irregularly shaped bodies in the deep dark can possess the same majestic features once thought unique to the gas giants. They consist of fine particles of water ice, caught in a narrow band that glimmers faintly in the distant starlight. This structure serves as a permanent halo, a glittering reminder of the violence that once reshaped this fast-spinning world. If we were to look closer, we would see that the moons and rings are intimately connected, with the satellites potentially acting as shepherds to keep the ring material confined. It is a fragile, beautiful arrangement, born from destruction, but sustained by the quiet, unrelenting laws of physics. If we venture further out to the brilliant world of Eris, we find a much more solitary arrangement, where the massive dwarf planet is accompanied by only a single known moon named Dysnomia. This distant sentinel takes over 2 weeks to complete a single orbit around its host, tracing a wide, slow arc through the vacuum. Its path is a testament to the sheer scale of the gravitational reach possessed by Eris, which holds its companion firmly even at such a staggering distance. As you contemplate the vast, slow-motion transit of this jagged satellite, allow your shoulders to settle and your weight to be fully accepted by the chair or floor. Feel the rhythmic pulse of your own heart, a steady internal clock that matches the unhurried pace of these distant orbital cycles. Let the quiet of your breathing mirror the profound stillness of the Iridian system, where time is measured in centuries. Dysnomia is thought to be composed of much darker material than the gleaming methane-frosted surface of Eris, making it a difficult object to spot against the blackness. This contrast creates a striking visual dichotomy, a bright shining queen of the cold pursued by a dark shadowy night. Their relationship is one of silent vigilance, a partnership that has endured through the long cold epochs of the outer system. These satellite systems were likely forged in the forge of giant impacts during the crowded, chaotic early days of the solar system's youth. In that era, the Kuiper Belt was far more populated, a dense swarm of protoplanetary bodies constantly jostling for space and crossing paths. Violent collisions were a frequent occurrence, as massive icy worlds slammed into each other at high speeds, pulverizing crusts and sending plumes of vaporized ice into the void. Much of this liberated material eventually escaped into space, or fell back onto the battered surfaces, but some of it remained trapped in orbit, coalescing over millions of years into the moons we see today. This theory of origin explains why so many Kuiper Belt moons share the same chemical signatures as the mantles of their parent bodies. They are, quite literally, the flesh and bone of the worlds they orbit, separated by trauma but bound by gravity. This history of impact-driven formation suggests that the outer solar system was once a place of intense kinetic energy and frequent change. The moons are the peaceful survivors of that ancient war, the settled debris of a time when the architecture of our star system was still being violently negotiated. Surprisingly, the presence of these moons provides astronomers with an invaluable scientific tool, as tracking their orbits allows for the precise calculation of the mass and density of both objects. Without a satellite to pull on, a distant dwarf planet remains a mystery of unknown weight and composition. By measuring the speed at which a moon circles its host and the distance of its path, the invisible strength of the parent's gravity is laid bare. This information is the key to unlocking the internal secrets of these worlds, telling us whether they are solid rock, mostly ice, or perhaps possess a hidden liquid interior. It is an exercise in celestial weighing, a way to probe the heart of a world billions of miles away, using nothing but the laws of motion. Through these measurements, we've learned that many of the belt's residents are surprisingly dense, containing more rock than their icy exteriors would suggest. Every transit of a jagged satellite across a distant star or its own host provides a fresh data point in this ongoing quest for understanding. The moons are not just companions, they are the scientific keys that open the doors to the hidden history of the outer disk. Deep within the belt, some binary objects exist as perfectly matched pairs of nearly equal size, spinning around a common centre of gravity in the empty space between them. Unlike the relationship between a giant planet and a tiny moon, these systems are true partnerships of equals, where neither body dominates the other. They tumble through the dark like a pair of dancers joined at the hands, their mutual attraction the only thing preventing them from flying apart into the void. Take another slow, grounding breath, noticing the balance of your own body and the way you are centered in your immediate environment. Just as these binary worlds find their equilibrium in the vacuum, feel yourself finding a point of rest and stability in the present moment. Let the tension in your jaw and neck dissolve, replaced by a sense of quiet symmetry and poise. This arrangement is particularly common among the cold classical population of the belt, those objects that have remained in their original orbit since formation. The existence of these equal binaries suggests they formed very gently, perhaps as two separate clouds of dust that collapse together in a slow, swirling embrace. They are the most delicate structures in the outer system, preserved fossils of the original accretion process that never experienced the violent disruptions seen elsewhere. Tidal forces in these binary systems can generate significant internal heat through a process known as tidal kneading, potentially keeping subsurface water liquid for millions of years. As the two bodies orbit one another, their mutual gravitational pull constantly stretches and compresses their interiors, creating friction at a molecular level. This mechanical energy is converted into heat, warming the cores of these worlds far above the freezing temperatures of the surrounding vacuum. This hidden furnace could theoretically support underground oceans of liquid water, even on worlds that are otherwise frozen solid on the surface. If ammonia or other salts are present to act as antifreeze, these oceans could persist for vast stretches of geological time. The idea of liquid water existing so far from the sun's warmth is a radical shift in our understanding of where habitable environments might hide in the cosmos. These gravitational interactions transform these binary pairs from dead blocks of ice into dynamic, potentially living worlds. The waltz of the moons is more than just a beautiful movement. It is a life-sustaining pulse that beats in the dark heart of the outer solar system. The intricate orbits of these small moon systems continue to challenge our fundamental understanding of how planetary bodies accrete and evolve. Modern computer models often struggle to explain how such a high percentage of Kuiper Belt objects ended up with satellites, especially those on wide, eccentric paths. The classic capture theory, where one body simply wanders into the gravitational trap of another, appears statistically unlikely given the vast distances and empty space involved. Instead, these systems point toward a more complex and crowded early environment, where the density of material allowed for unique gravitational interactions that we're only beginning to simulate. Some researchers suggest that these moons may have formed from a massive cloud of pebbles and dust that collapse simultaneously, birthing the parent and child as a single unified system. This would mean that the binary state is the original condition of many worlds, rather than an accidental byproduct of later events. Every new discovery of a moon around a distant KBO forces us to refine our math and rethink the story of our origins. The outer solar system is a laboratory of physics where the rules of formation are written in the subtle, jagged motions of moons we can barely see. Out in the quiet dark, these paired worlds will continue their slow, rhythmic waltz for the rest of the solar system's lifespan. Bound by the invisible threads of gravity, they are among the most stable and enduring relationships in the universe, largely immune to the perturbations that plague the inner planets. While the Sun will eventually expand and consume the terrestrial worlds, the residents of the Kuiper Belt will likely remain in their distant sanctuary, undisturbed by the dying star's final tantrums. They will drift onward through the eons, their orbits a permanent record of the ancient forces that brought them together. Long after the light of the Sun has faded into a white dwarf's dim glow, these icy partners will still be circling one another in the freezing gloom. Their dance is a marathon of cosmic proportions, a commitment to companionship that spans the entire history of our solar family. To witness this multitude of moons is to understand that the universe prefers connection over isolation. Even at the furthest edge of our reach, the dark is filled with the silent, graceful movements of worlds that refuse to wander alone. Yet, this refusal to wander alone extends far beneath the frozen crusts of these icy worlds, where a hidden, internal connection to their own ancient origins keeps their hearts surprisingly warm. Deep within the largest dwarf planets, the slow and metronomic decay of radioactive isotopes like potassium, thorium, and uranium provides a persistent pulse of thermal energy that defies the absolute zero of the surrounding vacuum. This internal furnace acts as a subterranean battery, releasing a steady trickle of heat that has lingered since the very birth of the solar system more than 4 billion years ago. It is a silent, invisible fire that prevents these distant bodies from becoming completely inert blocks of stone, allowing them to maintain a level of geological vitality that was once thought impossible at such extreme distances from the Sun. This internal warmth creates a profound dichotomy between the biting, crystalline cold of the surface and the churning, energetic activity occurring just a few miles below the ice. Without this radioactive heartbeat, the outer solar system would truly be a graveyard of static relics, forever frozen in the state they attained during their formation. Instead, the steady release of energy ensures that these worlds remain active participants in the ongoing evolution of our cosmic neighbourhood. As you consider this enduring internal glow, allow your own body to find a deeper state of rest, feeling the steady, rhythmic warmth of your own circulation as it grounds you in the present. Notice how this hidden vitality manifests on the surface of Pluto within the gargantuan, shimmering expanse of Sputnik Planitia. This vast basin of nitrogen ice is not a static plane, but a living, breathing landscape divided into a complex honeycomb of giant convection cells that are constantly in motion. Warmer ice from the depth slowly rises to the centre of these cells, spreads toward the edges, and eventually sinks back down to be reheated in a process that mirrors the slow boil of a thick planetary soup. This rhythmic churning ensures that the surface is perpetually refreshed, effectively erasing the scars of ancient impact craters and maintaining a pristine, youthful appearance. The scale of this geological dance is staggering, with each individual cell spanning several miles across and operating on a timescale of hundreds of thousands of years. It is a tectonic process occurring at temperatures so low they would instantly shatter steel, yet it flows with the grace and consistency of a slow-moving river. This constant renewal provides an ever-changing face to the King of the Belt, proving that even the most remote worlds are capable of profound self-transformation. The shimmering plains of nitrogen are a visual testament to the power of internal heat, a shimmering heart that beats in the silent dark of the outer disk. As you envision this slow, majestic churning of ice, let your shoulders drop and your jaw relax, finding a natural and effortless pace for your breathing. Feel the solid weight of your frame supported by the ground, a steady anchor as we observe the rhythmic flows of a world billions of miles away. Surprisingly, the universe allows for a bizarre form of volcanism that replaces scorching, molten rock with a freezing magma composed of water-ammonia mixtures. These cryovolcanoes, such as the towering Right Mons, stand as silent sentinels on the horizon, built from the slow, viscous accumulation of slushy eruptions that ooze from the interior. This cold lava behaves much like the thick flows seen on the inner rocky planets, but it freezes into permanence under the dim, silvery light of the distant sun. It is a geological paradox where the eruption of material signifies not a destructive heat, but the presence of a mobile, semi-liquid layer deep within a world of ice. The resulting landscapes are characterized by strange, scalloped terrains and rounded hummocks that look more like a frozen organic organism than a traditional mountain range. Because the eruptions are so cold, they do not explode with the violence of terrestrial volcanoes, but instead seep and crawl across the surface, filling in canyons and smoothing out jagged peaks. This cryomagmatic activity provides a direct conduit from the hidden interior to the airless exterior, bringing the secrets of the deep dark up into the light for us to see. It is a reminder that the forces of geology are universal, adapting to the extreme conditions of the deep freeze to create features of haunting and alien beauty. This structure of ice and slush represents a radical rethinking of planetary science, where magma is something you could touch without being burned, though it would instantly freeze your hands solid. These volcanoes are the heavy breathers of the outer solar system, exhaling the materials of the core to reshape the face of the world. Deep within these frigid territories, the very definition of a mountain is rewritten by peaks constructed entirely of rock-hard water ice that tower miles into the ink-black sky. At the extreme temperatures of the Kuiper Belt, water ice loses its slippery, fragile nature and begins to behave with the structural integrity and density of granite or basalt. This transformation allows it to support gargantuan massifs, such as the Tenzing Montes, which pierce the vacuum with jagged crystalline summits that never experience the softening touch of a thaw. These mountains are the skeletal remains of a world where ice has become the bedrock, a permanent and unyielding landscape shaped by the sheer pressure of its own weight. If we were to look closer at the roots of these mountains, we would see them diving deep into the crust, anchored by the same internal pressure that pushes them upward. They are the permanent features of a world that is otherwise defined by shifting glaciers and flowing nitrogen, the solid anchors in a sea of changing ice. If we were to look closer beneath these jagged crystalline crusts, we might discover that liquid water oceans still slosh in the profound darkness of objects like Pluto and perhaps even Eris. These hidden reservoirs are tucked away dozens of miles below the surface, protected from the lethal vacuum by a thick insulating shell of ice that acts as a planetary blanket to keep the internal heat trapped. In this subterranean abyss, a dark and silent sea exists as a permanent feature of the outer solar system, a surprising sanctuary of liquidity in a realm otherwise defined by the absolute solid. The existence of these oceans suggests that the frost line is not a wall, but a threshold behind which water can still persist in its most vital and mobile state. These dark seas may contain more liquid water than all of Earth's oceans combined, held in a pressurized state that has lasted for billions of years. They are the hidden hearts of the dwarf planets, the reservoirs of potential that drive the geological activity we see on the surface. Without these oceans, the cryovolcanoes would fall silent and the nitrogen plains would cease their churning, leaving only a dead and frozen shell. The discovery of these hidden waters has fundamentally shifted our understanding of the solar system, revealing that the majority of our neighbour's liquid water may be hiding in the furthest, coldest reaches of the Sun's domain. As you contemplate the vast, hidden depths of these dark oceans, let your mind rest in the stillness, feeling a sense of quiet wonder at the secrets tucked away in the shadows. Allow your breath to flow in and out like a slow, steady tide, a gentle resonance that connects you to the rhythmic pulses of the universe. This structure of liquid water is made possible by the presence of ammonia, which acts as a powerful and essential cosmic antifreeze within the planetary interior. By mixing with the water, ammonia significantly lowers its freezing point, allowing a liquid state to be maintained at temperatures where pure water would have long since turned to solid stone. This chemical synergy is the key to the geological longevity of the Kuiper Belt's kings, providing the lubrication necessary for crustal movement and the eruption of cryovolcanic material. It is a subtle but vital ingredient in the recipe for a dynamic world, proving that small variations in chemistry can have monumental impacts on the evolution of an entire planet. Ammonia is abundant in the outer solar system, having been preserved in the ice since the earliest days of the solar nebula's collapse. Its presence ensures that the internal oceans remain slushy and mobile, rather than freezing into a solid, unyielding mass that would crack the planet apart. This chemical antifreeze allows the hidden oceans to persist for eons, even as the world's internal heat slowly begins to fade over the turning of cosmic ages. It is the secret guardian of liquidity, a chemical bridge that allows the dark seas to survive in a place where heat is the rarest of commodities. This chemical resilience is what allows these worlds to remain geologically alive long after they should have cooled to the core. Ammonia turns a death sentence for a liquid ocean into a lease on life that lasts for billions of years. Imagine a world where the surface is crisscrossed by gargantuan fissures and deep canyons, such as the Virgil Fossé, which speak of a violent and unstoppable internal expansion. These features suggest that as the internal oceans slowly began to freeze over eons, the expanding ice pushed outward with a force that shattered the brittle, sun-darkened crust above. This geological scarring is a record of a world's struggle to contain its own changing volume, a slow-motion explosion written permanently into the ice. Each deep, shadowed trench is a monument to the immense pressure of a freezing heart, a physical manifestation of a world that is still growing and shifting in the dark. The canyons of the Kuiper Belt are often deep enough to swallow the tallest mountains of Earth, their walls showing the layered history of the world's crust like the rings of an ancient tree. They reveal the sheer power of water as it transitions from liquid to solid, a phase change that can rip a planet's surface asunder. These fissures also provide a glimpse into the interior, as the fresh white ice exposed in the depths of the canyons provides a stark contrast to the red, tholin-covered plains above. They are the stretch marks of a world in transition, the visible evidence of a geological heartbeat that refuses to be silenced by the cold. As you visualize these deep, silent canyons, feel the tension in your neck and shoulders melt away, replaced by a sense of vast, open space. Let your breathing remain steady and deep, a calming anchor as we explore the fractured landscapes of the outer frontier. Surprisingly, the gravitational tug-of-war between these worlds and their large moons helps keep these hidden oceans from freezing into a completely solid state. The constant rhythmic stretching and compression caused by the proximity of a massive satellite like Charon generates significant additional heat through internal friction, a process known as tidal kneading. This gravitational interaction acts as a secondary furnace, a perpetual massage that keeps the water mobile and the internal geological heartbeat steady over billions of years. It is a beautiful example of how the connection between two worlds can literally keep the heart of one beating against the cold of the void. This tidal heating is particularly effective in binary systems, where the bodies are close and their orbits are slightly eccentric, ensuring that the gravitational pull is constantly changing. The energy produced by this kneading is enough to maintain a thin layer of liquid water even on smaller bodies that would otherwise be frozen to the core. It proves that the multitude of moons is not just a visual wonder, but a functional necessity for the preservation of geological activity in the deep dark. The dance of the satellites is a life-sustaining pulse, a cosmic rhythm that generates warmth from the simple act of being together. This synergy between gravity and heat reveals a solar system that is far more interconnected than we ever suspected. The survival of a dark, liquid ocean depends as much on its neighbour's pull as it does on its own internal chemistry. This hidden geological heartbeat means the Kuiper Belt is not the static, silent graveyard once imagined by early astronomers, but rather a dynamic and ever-changing environment. Far from being a collection of dead relics, the trans-Neptunian region is populated by worlds that are geologically alive, with surfaces that are being actively reworked even in the present day. The twilight threshold is a place of movement, of rising nitrogen plumes, shifting glaciers, and erupting cryovolcanoes that defy the absolute stillness of space. To understand this region is to recognize that change is a fundamental constant of the universe, persisting even at the very edge of the sun's light. The discovery of active geology so far from the sun has forced a complete rewriting of planetary evolution models, proving that heat and movement are not the sole domain of the inner planets. The Kuiper Belt is a vibrant frontier where the landscape is being continuously sculpted by internal forces that we are only beginning to comprehend. Every new image of a smooth, crater-free plain or a fresh volcanic vent is a reminder that the solar system still has the power to surprise us with its vitality. It is a place of ongoing creation, where the ancient material of the nebula is still being churned and transformed by the persistent warmth of the deep. This realization transforms the belt from a historical archive into a living laboratory. We are not just looking at the past, we are witnessing the active, unfolding present of a vast and complex territory. While the surface is a lethal vacuum of extreme cold and radiation, the deep oceans provide a stable, protected environment where chemistry could theoretically evolve into biology. The same tholins and organic compounds that paint the surface red are available to be pulled into the interior through the cracks and fissures, providing the raw materials for a hidden biosphere. This radical shift in perspective means that the search for life is no longer limited to the habitable zone of a star, but can extend to any world with a warm heart and a protective shell of ice. The Kuiper Belt is the ultimate frontier in our quest to understand our place in the universe, a silent sanctuary of potential that stretches across the vastness of space. In this way, the outer solar system is not an end, but a beginning, a source of potential that whispers to us from the shadows of the deep dark. These whispers from the shadows of the deep dark were not always so hushed, for the early solar system was a much more crowded and intimate place. According to the sophisticated framework of the Nice model, the ancestral Kuiper Belt was once a dense, concentrated ring of icy material located much closer to the sun than its current position. In those primitive days, the giant planets lived in a compact configuration, huddled together before the Great Scattering began to tear the neighbourhood apart. This ancestral disk was thick with potential worlds, a swirling ocean of ice that occupied the space where Neptune now resides. It was a time of immense proximity, where the gravitational influences of the giants and the icy fragments were in a state of delicate, high-pressure tension. The belt we see now is but a ghost of this original massive structure, which once contained enough material to build dozens of Earths. If we were to look closer at this ancient era, we would see a solar system that felt solid and connected, a single continuum of matter before the void began to expand. This original density provided the raw energy for the chaos that was about to follow. It was the calm before a cosmic storm that would permanently redefine the limits of our star's domain. Surprisingly, the catalyst for the greatest upheaval in our history was a slow, subtle shift in the orbits of the two largest giants, Jupiter and Saturn. As they interacted with the leftover debris of formation, their paths began to drift until they reached a critical gravitational resonance, crossing a threshold where Saturn completed exactly one orbit for every two of Jupiter. This mathematical alignment acted like a massive slingshot, sending a shockwave of energy through the entire system and destabilizing the outer planets. This resonance forced Uranus and Neptune to violently migrate outward, pushing them into the pristine fields of ice that had previously sat undisturbed. The orbits of the ice giants were no longer stable circles, but became erratic and powerful as they were shoved toward the periphery. It was a moment of supreme imbalance, where the internal clockwork of the planets suddenly accelerated into a frantic outward rush. As you consider this massive planetary shift, allow your body to settle into a state of heavy relaxation, feeling the steady gravitational pull of the Earth beneath you. Notice the effortless way your breath flows in and out, a quiet and stable rhythm amidst the imagined chaos of the ancient past. The migration of the giants was a slow-motion catastrophe that took millions of years to unfold, yet it forever broke the original order of the Sun's family. This cosmic structure was forever altered when Neptune ploughed into the primordial disk of ice, scattering objects in all directions like a massive bowling ball hitting a set of fragile pins. The terrifying, silent rush of the blue giant through the dense fields of debris created a wave of gravitational destruction that few objects could escape. As Neptune migrated further into the disk, its immense mass acted as a kinetic plough, lifting trillions of frozen fragments out of their stable paths and hurling them into the abyss. The collision between the planetary giant and the icy disk was not a physical impact, but a violent gravitational encounter that reshaped the trajectories of everything in its path. Imagine the sight of an entire world, thousands of times more massive than the fragments it displaced, sweeping through the twilight and leaving a trail of chaos in its wake. This was the defining moment of the scattering, a process of clearing that transformed a crowded neighborhood into the sparse wilderness we observe today. Some objects were thrown inward toward the sun, while others were flung outward toward the interstellar void, their ancient histories erased in a single gravitational heartbeat. Neptune's migration was the primary engine of the belt's architecture, a brutal sorting process that determined which worlds would stay and which would be lost forever. It was a masterclass in the sheer, unyielding power of planetary mass to reorganize the cosmos. The scale of this event was so profound that up to 99% of the original mass of the Kuiper Belt was either thrown into deep space or hurled into the inner solar system. What remains today is merely a tiny skeletal remnant of a once mighty population, a scattering of survivors in a region that was once teemingly dense. The vast majority of the primordial building blocks were expelled, lost to the eternal dark or consumed by the growing planets in a massive clearing of the cosmic table. Deep within this expulsion, the loss of material represented the disappearance of thousands of potential dwarf planets and millions of comets. The solar system literally thinned itself out, casting away its excess material in a frantic attempt to find gravitational equilibrium. This mass loss is one of the most significant events in the history of our neighborhood, ensuring that the outer reaches would remain a place of lonely isolation. If we were to look closer at the sheer volume of expelled ice, we would realize that our current maps are based on less than 1% of the original story. The belt is not a thriving metropolis, but a sparsely populated ruins, the leftover debris of a massive cosmic eviction. Every object we discover today is a lucky survivor of a process that removed almost everything else. This catastrophic disruption triggered a period of extreme violence known as the Late Heavy Bombardment, raining trillions of comets down upon the young cooling Earth and its neighbours. As the ice giants scattered the Kuiper Belt, they sent a massive pulse of icy projectiles inward, turning the inner solar system into a cosmic shooting gallery. The Moon's battered face is the permanent record of this era, its craters serving as the silent scars of the icy rain that once fell from the outer dark. Earth itself was not spared, enduring a relentless barrage of impacts that reshaped its surface and perhaps even altered its atmosphere. This period of bombardment was a direct consequence of the Great Scattering, a moment where the outer system reached in to touch the inner worlds with violent force. It was a time of fire and ice, where the cooling rocks of the inner planets were hammered by the frozen remnants of the distant frontier. As you imagine this rain of comets, feel the absolute stillness of your own environment, a peaceful contrast to the ancient fury of the bombardment. Take a slow, grounding breath, noticing the air in your lungs and the safety of the world around you. This bombardment was a necessary crucible, a chaotic phase that eventually settled into the stable environment we now call home. Surprisingly, the water in our vast oceans may have been delivered by these scattered Kuiper Belt objects during this era of chaotic bombardment. Each icy projectile that struck the young Earth carried a cargo of frozen water and organic compounds, contributing to the growing reservoirs of our planet's life-giving fluids. The very seas we sail today may be composed of melted fragments from the trans-Neptunian dark, brought to us by the migration of the giant planets. This connection links our most vital resource directly to the frozen wasteland at the edge of the sun's reach. The Great Scattering was not just a story of destruction, but a process of delivery, transporting the building blocks of habitability from the cold reservoir to the warm inner cradle. Without the violent outward rush of Neptune, the Earth might have remained a dry and desolate rock, lacking the moisture required for life to flourish. It is a staggering realization that the salt in our tears and the water in our cells may have spent billions of years as ice in the deep dark before being hurled toward us. Our existence is fundamentally tied to the orbital dance of the giants and the scattering of the icy disk. The oceans are, in a very real sense, the liquid remains of the ancient Kuiper Belt. Only a tiny fraction of the original population managed to survive this era of upheaval, settling into the sparse and stable orbits we observe in the modern era. These resilient wanderers are the ones that were caught in stable resonances or managed to stay far enough away from the migrating giants to avoid expulsion. They represent the lucky few, the objects that found a safe harbour while the rest of their siblings were being cast into the void. This surviving population provides the only direct evidence we have of the primordial conditions that existed before the scattering began. Because they occupy stable niches, they have remained largely untouched for billions of years, serving as the ultimate long-term residents of the outer system. They are the elders of the belt, silent witnesses to a time of unimaginable chaos and planetary movement. Deep within their frozen crusts, these survivors hold the memory of the dense disk that once was, preserving the chemical and physical signatures of a lost era. They are the precious few pieces of a puzzle that was mostly destroyed, the fragments from which we must reconstruct the whole. The sparseness of the current belt is a testament to the severity of the scattering that preceded it. Many objects were not merely moved, but were ejected entirely from the sun's gravitational grasp, wandering forever as rogue planetesimals in the cold interstellar space between stars. These lost worlds are the true orphans of the Great Scattering, cast out into a permanent exile where no sun will ever warm them again. They drift in the absolute dark of the galaxy, carrying the chemistry of our solar system into the wide, empty spaces of the Milky Way. There may be trillions of these rogue icy worlds floating in the void, a hidden population of wanderers that outnumbers the planets themselves. Some of them may eventually wander near other stars, becoming interstellar visitors like the mysterious Oumuamua that briefly graced our own skies. They are the scattered seeds of our system, spread across the galaxy by the violent migration of our own giant planets. Notice the profound quiet of this image, the thought of a lonely world drifting forever through the star-studded abyss. Allow your own mind to find a similar sense of quiet and space, letting go of any remaining tension as you breathe with the rhythm of the stars. These rogue planetesimals are the silent ambassadors of our origin, wandering the universe long after their home has changed beyond recognition. This structure of the current belt is essentially a cosmic crime scene left over from this ancient planetary upheaval, with every orbit acting as a piece of forensic evidence. Astronomers do not see the scattering as it happens, but instead look at the distorted, tilted and grouped paths of the survivors to work backward to the cause. The fingerprints of Neptune and the other giants are all over the belt, written in the specific mathematical ratios and inclinations of the icy bodies. By analysing the damage, scientists can determine the velocity of Neptune's migration and the exact moment the resonance between Jupiter and Saturn was crossed. Every gap in the disk and every cluster of objects is a clue, revealing the direction and force of the gravitational winds that once blew through this region. It is an exercise in celestial archaeology, where the artifacts are moving worlds and the site is the entire outer solar system. The guilt of the giant planets is undeniable, as their current positions can only be explained by the massive reorganization of the outer disk. We live in the aftermath of a great cosmic rearrangement, a stable system built on the ruins of a much more crowded past. The crime scene is vast, but it is through these clues that we finally understand how our home came to be. By mapping these scattered survivors, astronomers are slowly and meticulously piecing together the violent history of our cosmic neighbourhood. Every new discovery of a distant, eccentric object adds a fresh data point to the simulations, allowing us to refine the timeline of the Great Scattering with increasing precision. We are the detectives of the deep dark, using the light of distant stars and the shadows of frozen worlds to reconstruct the biography of our Sun. This reconstruction reveals that the solar system is not a static machine, but a dynamic and often violent entity that has undergone profound transformations. The order we see today was purchased at the price of nearly everything else that once existed in the outer disk. It is a story of loss, movement, and the eventual arrival of stability, a narrative that explains the very structure of the sky we see at night. The history of the Kuiper Belt is the history of the giant planets themselves, a shared journey of migration and scattering that define the limits of our world. As we look out into the dark, we are not just seeing rocks, we are seeing the last standing witnesses of a time when the universe was still deciding where everything belonged. The sense of belonging shifts as we move toward the periphery, where the Kuiper Belt exists in a fragile boundary zone, where the solar wind begins to lose its battle against interstellar space. For billions of miles, the Sun has exhaled a constant stream of charged particles known as the solar wind, creating a protective bubble called the heliosphere that shields the planets from the harsh environment of the galaxy. Out here, however, that solar breath slows to a whisper, weakened by the immense distance and the mounting pressure of the cold, thin gas between the stars. It is a place of profound transition, where the internal energy of our star system finally encounters the vast ancient currents of the interstellar medium. This invisible threshold marks the true limit of our Sun's physical reach, a shoreline where the solar wind finally yields to the cosmic winds of the Milky Way. New Horizons, currently the only spacecraft to deeply explore this remote and quiet region, detects a steady and measurable drop in the density of solar particles as it pushes further into the gloom. Its instruments capture the fading pulse of the Sun, recording an environment that is becoming increasingly dominated by the silent, high-energy vacuum of deep space. This lone explorer serves as our sensory outpost, translating the invisible thinning of the heliosphere into data that we can finally comprehend from our distant home billions of miles away. Each mile it travels brings us closer to the true edge, where the familiar physics of the solar neighbourhood give way to the mysteries of the interstellar medium. The data it sends back is the first of its kind, a pioneer's report from the very boundary of our celestial home, proving that the sun's protection is not infinite. Surprisingly, the universe reveals a harsher reality for these distant worlds, as cosmic rays from ancient distant supernovas strike their surfaces with far more intensity than they do on Earth. Without a thick atmosphere or a powerful global magnetic field to deflect these high-energy particles, the icy crusts of the Kuiper Belt are bombarded by the remnants of stellar explosions from across the galaxy. This relentless rain of radiation acts as a chemical sculptor, breaking down simple molecules and contributing to the darkening and reddening of the ancient ices over eons of time. It is a reminder that while these worlds are far from our sun, they are intimately connected to the violent life cycles of stars throughout the Milky Way. Notice the gentle weight of your own body, safe and shielded by the Earth's embrace, as you breathe in the quiet air of your surroundings. Deep within the belt, the quiet is punctuated by a faint infrared glowing disk of dust, produced by the constant slow-motion collisions between icy fragments over millions of years. This microscopic debris does not simply vanish, but instead lingers in a wide, shimmering shroud that extends outward toward the heliopause. While invisible to the human eye, this dust captures the sun's meagre heat and re-radiates it as a ghostly glow that can be detected by our most sensitive space telescopes. It forms a celestial ring of smoke, a luminous signature of the ongoing geological and orbital interactions that continue to shape the belt, even in its sparse modern state. This dust disk is a fingerprint of the belt's activity, a glowing reminder that the outer solar system is not a static void, but a place of constant, subtle movement. This cosmic structure is further complicated as the dust interacts with the interstellar magnetic field, creating a complex web of charged particles at the very edge of the solar system. The microscopic grains of ice and rock become electrically charged by the sun's radiation, allowing them to be nudged and channeled by the invisible magnetic currents flowing through the galaxy. This interaction creates a vast, shimmering curtain of particles that marks the transition from our star's domain to the true interstellar void. It is an intricate magnetic tapestry that reminds us that even the smallest fragments of ice are part of a larger galactic architecture. This interaction is one of the few ways the galaxy can directly influence the material inside our solar system, weaving our home into the larger fabric of the Milky Way. If we were to look closer at the history of our exploration, we would find that the Pioneer and Voyager probes passed through this region decades ago, though their cameras were already shut down to conserve their dwindling power. These silent messengers crossed the threshold of the belt in total darkness, unable to send back images of the icy worlds they might have encountered on their long way to the stars. We are left to imagine the sights they passed, the jagged silhouettes of binary worlds and the rust-coloured plains of distant dwarf planets that they missed by mere millions of miles. They continue their journey as blind ambassadors, carrying our presence into the galaxy while leaving the visual mysteries of the belt to the explorers who followed. Take a moment to feel the solid support of your chair or floor, grounding you in a world of light and clarity while our probes wander the eternal dark. Studying the Kuiper Belt helps us fundamentally understand the debris disks observed around other young stars in our galaxy, serving as a nearby laboratory for the evolution of planetary systems. When we point our telescopes at distant suns like Fomalhaut or Vega, we see massive rings of dust and ice that bear a striking resemblance to our own trans-Neptunian region. By mapping the architecture of our home belt, we can decode the history and formation of these alien worlds, realizing that the processes that shaped our neighborhood are universal across the cosmos. The Kuiper Belt is the Rosetta Stone for the outer reaches of the galaxy, a familiar guide to the cold, distant frontiers of countless other stars. It provides a bridge between our specific history and the general rules of how planets and disks evolve throughout the universe. This structure does not end with a sharp boundary, as the exact outer edge of the belt remains undefined, fading slowly into the even more mysterious and distant Oort cloud. the density of icy objects simply tapers off, with the orbits becoming increasingly stretched and eccentric until they are no longer part of a flat, organised disk. This transition zone is a realm of extreme isolation, where the sun's gravity is so weak that it can barely hold on to its frozen children against the tug of distant stars. It is a slow fade into the true abyss, a gradual thinning of material that eventually gives way to the gargantuan spherical shell of comets that surrounds our entire star system. Out here, the very concept of a belt begins to dissolve into a sphere of lonely wanderers. Surprisingly, the orbits of the outermost Kuiper Belt objects have been subtly altered over billions of years by the gravity of passing stars that drifted near our solar system in the distant past. In its long journey around the centre of the galaxy, the Sun occasionally encounters other stellar neighbours, whose invisible pull can nudge the most distant icy bodies into new, unusual paths. These encounters leave behind gravitational scars, creating a population of detached objects that no longer seem to belong to the main disk of the belt. These wanderers are the celestial records of ancient flybys, proof that our solar system is not an island, but a participant in a vast, slow-motion dance with the rest of the stars in the Milky Way. Allow your breath to flow naturally, feeling the quiet pulse of life within you as you contemplate the vast rhythmic movements of the stars. Out here, at the furthest reaches of the edge of the wind, the influence of the sun is so weak that the gravity of the Milky Way galaxy itself begins to play a measurable role in the movement of objects. This galactic tide exerts a subtle but persistent pressure, slowly twisting the orbits of the most distant icy worlds and aligning them with the centre of our galaxy. It is the final transition of power, the moment where our star finally surrenders its authority to the massive spinning collective of the Milky Way. In this profound silence, the Kuiper Belt becomes a bridge between our home system and the infinite expanse of the stars, a place where we finally truly begin to join the galaxy at large. It is the ultimate frontier, where the solar system ends and the rest of the universe begins. Within this ultimate frontier, where the solar system ends and the rest of the universe begins, a haunting mathematical pattern has emerged from the profound darkness. Astronomers have recently noticed that the most distant known objects in the Kuiper Belt do not wander randomly through the abyss, but instead share a strange and synchronized alignment. Their elongated, elliptical orbits all point in roughly the same direction and tilt at remarkably similar angles, as if they are being herded by an invisible shepherd across the sky. This clustering is statistically impossible to occur by pure chance, suggesting that a massive hidden influence is actively sculpting the far reaches of our star system. It is a ghostly signature written in the paths of ice, a physical hint that our census of the solar system's major players remains fundamentally incomplete. These distant wanderers act like a school of fish moving in unison, their paths dictated by a presence we cannot yet see, but whose strength is undeniable. If we were to look closer at the geometry of these paths, we would see a cluster of extreme orbits stretching out together into the unknown dark. It is a visual representation of a gravitational secret, a silent choreography that points toward a discovery that could change everything we know about our home. Mathematical models and rigorous computer simulations indicate that this hidden shepherd could be a hypothetical world known as Planet 9. This unseen giant is estimated to be up to 10 times the mass of Earth, making it a super-Earth or mini-Neptune that has evaded our gaze for centuries. If it exists, it would be the first major planet discovered in our system since the 19th century, fundamentally redrawing the maps of our local cosmic neighbourhood. Its gravity would be powerful enough to explain the odd behaviour of the distant icy fragments, acting as a massive anchor in the outer dark. This world represents the missing piece of a grand gravitational puzzle, a phantom presence that challenges our understanding of how many planets truly circle our sun. The existence of such a massive body so far from the light would prove that the planetary family is far more extensive than we previously dared to imagine. Surprisingly, The sheer scale of this hypothetical world means it would dominate the dynamics of the entire outer belt. It would be a cold, heavy king of the twilight, reigning over a kingdom of ice from the deepest shadows. Finding it would be the crowning achievement of modern astronomy, turning a mathematical suspicion into a physical reality. If this unseen giant truly haunts the periphery, its journey around the sun would be a marathon of truly epic proportions, taking between 10,000 and 20,000 years to complete a single orbit. At its furthest point, it would drift hundreds of times further from the sun than the Earth, existing in a state of permanent, deep frozen twilight. Such a massive distance means that a single year on Planet 9 would encompass the entire rise and fall of human civilizations. It would move with an agonizing slowness, a majestic and lonely sentinel tracing a path through the outermost reaches of the sun's gravitational authority. The scale of this orbit is almost beyond comprehension, situating the planet in a realm where the sun's light is little more than a brilliant cold pinprick. Every single revolution would take the planet through eons of history, a silent observer of the solar system's slow, rhythmic turning. This incredible orbital period is one reason the planet has remained hidden for so long, as it spends the vast majority of its time in the deepest, most remote parts of its path. It is a world that operates on a geological timescale, its movements measured in millennia rather than months. To find it, we must catch a glimpse of a body that only passes through its nearby regions once every 100 generations. It is a democratic form of gravity, where the collective weight of the belt itself defines the architecture of the deep. This model relies on the idea that the sheer number of objects in the outer reaches creates a persistent gravitational field that keeps the extreme orbits aligned. If this theory is correct, then the Planet 9 we seek is not a single world, but the combined voice of an entire region of space. Surprisingly, the universe often offers multiple explanations for the same mystery, leaving us to sift through the data for the truth. As you weigh these competing theories, take a moment to notice the quiet stillness of your own hands. Let your fingers rest heavily and without effort, feeling the calm stability of the world around you, while the cosmos debates its hidden structures. Another radical and mind-bending theory suggests that the gravitational anomaly might not be caused by a planet or a disk at all, but by a primordial black hole the size of a grapefruit. This ancient relic of the Big Bang would possess the mass of a large planet, but occupy a space so small it would be virtually impossible to see with traditional telescopes. If such a tiny, high-density object were captured by our sun's gravity in the distant past, it would silently exert the same pull as a massive world. This possibility introduces an element of exotic physics to our very own backyard, suggesting that the most familiar of systems might harbour the most extraordinary of cosmic secrets. It is a jarring thought that a piece of the early universe's ultimate power could be hiding among the icy rocks of the Kuiper Belt. Such an object would emit no light of its own, remaining invisible until it happened to block the light of a distant star or nudge a passing comet. The presence of a primordial black hole would turn the Kuiper Belt into a laboratory for the most extreme physics imaginable. It represents the ultimate limit of our ability to perceive the contents of our own system. Whether it is a planet or a singularity, the source of the pull remains one of the most compelling ghosts in the modern sky. The search for this hidden mass has pushed our telescope technology and deep sky surveys to their absolute limits, testing the boundaries of what we can detect in the ink-black void. Astronomers must peer through the thick dust of our own Milky Way galaxy and sift through millions of distant stars to find a single, moving point of light that barely reflects the sun's glow. This hunt requires the most sensitive infrared sensors and the most powerful supercomputers to analyze vast amounts of data for the tiniest gravitational wobbles. We are currently searching the sky with a precision that was unimaginable only a few decades ago, essentially looking for a needle in a hayfield the size of the solar system. The challenge is not just the distance, but the extreme faintness of any object existing so far from the sun's illuminating rays. Every survey that comes up empty narrows down the possible hiding places, forcing us to look deeper and further into the unknown. This search is a testament to human curiosity and the relentless drive to map the unknown corners of our world. It is a high-stakes game of cosmic hide-and-seek where the prize is the discovery of a new world. Even if we find nothing, the search itself is expanding our understanding of the universe's most remote territories. Every new extreme Kuiper Belt object discovered adds a crucial and irreplaceable data point to this ongoing, astronomical detective story. These distant wanderers are the clues left at the crime scene of the early solar system, their orbits providing the mathematical trail that leads toward the hidden mass. By plotting the paths of these extreme trans-Neptunian objects, scientists can narrow down the region of the sky where a hidden planet or disk might be lurking. It is a slow and methodical reconstruction, a puzzle being assembled one frozen fragment at a time. Each discovery of a new object with a clustered orbit strengthens the case for an unseen shepherd, adding weight to the mathematical predictions. We are mapping the invisible by watching how it moves the visible, a technique that has revealed many of the universe's greatest secrets. Notice the soft, steady rhythm of your breathing as the puzzle pieces fall into place. Feel the air enter and leave your body with a natural ease, providing a quiet background to the intense focus of this cosmic search. The journey through the dark is long, but every discovery brings us closer to a final understanding of our home. Whether the hidden influence is a massive planet, a collective disk of debris, or even a clever gravitational illusion, the distant Kuiper Belt clearly hides mechanisms that we do not yet fully understand. The clustering of orbits is an undeniable physical reality that demands an explanation, forcing us to admit that our models of the solar system are still incomplete. This mystery proves that gravity can weave patterns in the dark that are far more subtle and complex than our early theories predicted. We are witnessing the limits of our knowledge, the point where observation meets the unknown and forces us to rethink the very nature of planetary neighbourhoods. The belt is not just a collection of rocks, but a dynamic system governed by invisible hands that we are only now starting to sense. It reminds us that nature always has more secrets than we have theories, and that the universe is never as simple as it first appears. This structure of the unknown is what drives science forward, inviting us to look closer and think more deeply about the world around us. The Kuiper Belt is a place where the rules are still being written, and where every discovery opens a door to a new set of questions. It is the ultimate playground for the curious mind, a realm of shadows where the light of reason is just beginning to shine. This paradox proves that even within the familiar confines of our own solar system, there are still vast, uncharted frontiers awaiting discovery. We often think of the planets as a finished set, yet the Kuiper Belt reminds us that we have only explored the sunlit porch of a much larger and darker mansion. There are regions of space just beyond Neptune that contain more secrets than the entire inner solar system combined, waiting for the next generation of telescopes and probes to unveil them. It is a humbling realization that we can live in a system for millions of years and still not know the names or faces of all our neighbours. The frontier is not just in distant galaxies, but right here at the edge of the sun's fading wind. This proximity makes the mysteries of the belt even more tantalizing, as they are within our reach if only we have the courage and the technology to look. The Kuiper Belt is our local wilderness, a place of extreme conditions and ancient beauty that continues to challenge our place in the cosmos. It reminds us that exploration is not a task that is ever truly finished, but an ongoing journey into the heart of the unknown. As we peer into the dark, we are not just looking at space, we are looking at the future of our own discovery. The fundamental answers to the formation and evolution of our planetary family lie locked within these deepest, coldest reaches of the sun's domain. By understanding the forces that shape the Kuiper Belt and the objects that dwell within it, we can finally piece together the violent and beautiful history of how the Earth was born. This icy archive preserves the original chemistry and dynamics of the solar nebula, offering a pristine record that has been lost elsewhere in the system. To explore the belt is to go back to the very beginning, to see the raw materials of creation before they were forged into the worlds we know. Every frozen fragment and every clustered orbit is a piece of our own biography, a story written in ice and gravity that spans 4 billion years. The keys to our past are hidden in the twilight, waiting for us to unlock the secrets they have guarded for eons. As we reach the conclusion of this journey, allow your entire body to release any remaining tension, feeling a sense of deep and total relaxation. Notice the weight of your head, the softness of your jaw, and the quiet peace of your mind as we stand at the threshold of the ultimate discovery. The answers are there, waiting in the dark, held in the frozen grip of the outer system. The Kuiper Belt is not merely a graveyard of frozen debris, but a vast, whispering archive of our solar system's violent birth, holding both the water that sparked life on Earth and the unsolved mysteries of the deep cosmos. The Kuiper Belt is not merely a graveyard of frozen debris, but a vast, whispering archive of our solar system's violent birth, holding both the water that sparked life on Earth and the unsolved mysteries of the deep cosmos. Deep within the stillness of your own room, the vastness of the outer reaches begins to fold inward, settling into the quiet rhythm of your resting form. This cosmic journey across trillions of miles of ice and shadow now finds its anchor here, in the gentle weight of your body against the mattress. Surprisingly, the same atoms that drift in the cold classical disk are the very ones that allow you to feel the soft pressure of the sheets against your skin. Begin to notice your toes, letting them feel heavy and completely still as the cold starlight of the outer belt fades from your mind. This quiet energy travels up through the arches of your feet and into your ankles, releasing the last lingering tension of the day. Your calves and knees soften, sinking into the support beneath you like the slow oozing nitrogen glaciers we witnessed in the dark. The weight of your thighs and hips becomes absolute, grounded and immovable in this peaceful moment. If we were to look closer, we would see your breathing becoming a steady, low-frequency tide, echoing the metronomic sweep of the gravitational resonances that organize the heavens. Your lower back and spine relax, one vertebra at a time, surrendering to the profound silence that has followed us back from the edge of the sun's wind. This quiet room is a sanctuary of absolute softness, where the only movement is the slow, rhythmic expansion of your lungs. Every muscle in your hands and fingers now lets go, feeling a pleasant warmth as they rest motionless by your side. The weight of your forearms and shoulders dissolves, leaving behind a sensation of floating in a sea of velvet and shadow. Notice the way your neck releases its final hold, allowing your head to sink deeply into the pillow's cool embrace. The tiny muscles around your eyes and jaw smooth out, becoming as calm as a still lake in the middle of a forest. Your forehead feels broad and cool, empty of all thoughts and open to the restorative power of the night. Every breath you take now is a gift of pure relaxation, drawing in the stillness of the air and releasing any remaining traces of the world outside. The mattress supports you completely, claiming every ounce of your weight so you no longer have to hold yourself up. You're cocooned in the gentle dark of this room, far away from any noise or light or motion. This internal quiet is the only thing that remains, a soft and steady hum that lulls you deeper into the blankets. The world beyond this door is gone, replaced by the comforting reality of your own pulse and the heavy, peaceful pull of sleep. Everything is exactly as it should be in this moment of total surrender. The covers are a warm landscape of safety, wrapping around you like a soft cloud that never ends. You're drifting now, moving toward a place where words are no longer needed and the mind is free to rest. Peace flows through you with every heartbeat, washing away the edges of the day until only the dreamless dark remains. And now, 101 wonders are resting with you. Sleep now. Good night.